All right, so why do we need all that information? Well, if you have a statement like, you know, if Al is at the party, then Cindy will be at the party. And you know that it's true that Al is at the party, and you know it's false that Cindy is at the party. Then what you can do is you can say, well, if A is true and C is false, then this becomes false. And you can actually evaluate, is this statement true or false, by simply plugging in the truth values for everything. So we usually just write right below it instead of doing it separate. And so if you have a statement like A horseshoe B dot C wedge D, and you put in parentheses, and let's pretend A and B are true. So you write the truth value in below them, and let's pretend C and D are false, right? Then we can say, well, if A, then B. And we can say, okay, so we can just write these in below. They're both true, and C and D are false. Then we can take and go, okay, well, let's just go ahead and write this back out here like this. So we've now replaced these values. Well, we know F wedge F is false, right? And we know true horseshoe true is true. So we now have true dot false, and true dot false is false. So we can determine that this is a false statement if we know the truth value of all the parts. And so one of the things that makes this nice is if you get a long statement and you get a statement like, brackets A horseshoe B dot C parentheses wedge. Let me just erase a little bit, sorry. I have to, once I get started erasing, I have to erase the whole thing. Otherwise it annoys me on some level, and I know it's probably not the healthiest thing, but anyway, and then you have Z wedge R triple bar D, okay? Now let's pretend that A is true, B is false, C is true, Z is true, R is false, and D is true, okay? I'm just making these up as we go along. We can write that in if we know them, and write that back down, and wedge dot parentheses horseshoe and then brackets there. So we now go to the things inside parentheses. We have false dot true, which is false. So we now have true horseshoe false parentheses wedge, and we have T wedge F, and T wedge F is true, and we just copy this part down, okay? True triple bar true is true, and true horseshoe false is false, and we just copy down that. So we now have false wedge true, and that would be true. I started too low on the page. So we can kind of work our way down and find out this is a true statement. That whenever A is true and B is false and C is true and Z is true and R is false and D is true, if we can determine the truth value of the parts, we can determine the veracity of that statement. That statement's truth value is a function of it. Now, with that said, that's all nice and good, but what if you don't know if these are true or false? What if you have a statement like A horseshoe tilde B, and I don't know if A is true or B is false? Well, then what we need to do is we do what's called a truth table. And a truth table allows us to evaluate all the possible truth values for this statement. When will this statement be true and when will this statement be false? And we can evaluate that. And we can classify the statement according to logic. We can classify it as, we can label it as tautologous, self-contradictory, or a conditional statement, where the conditional means depending upon the truth value of the parts, the truth function is going to be determined. Tautologous means that the truth of the parts doesn't matter, the statement's always true, and self-contradictory means the statement contradicts itself, and it doesn't matter if the parts are true or false, it's always going to be false. Now, before we do all that, before we learn how to classify statements, we can take this and look and say, well, how do we do this? Well, there's a little rule, and we have the letter N. N is the number of letters in the compound statement. And then what we do is we have n squared. Is that right? No, sorry, I did it backwards. It's 2 to the power of n, or 2 to the power of n. So if you have two unique letters, then it becomes 2 to the power of 2, or 2 times 2, which equals 4. Which means in order to find out every possible truth combination, you have to have 4 lines, 2 to the power of n. And so you would start off and you would say 4, and so you do 2 trues and 2 falses. And then you would go half of 2 is 1, so you go 1 true, 1 false, 1 true, 1 false. And you would then come over and you would do the tilde, and you'd make it false, true, false, true. We put a little line through that so you don't look at that anymore. And then true horseshoe false is true. True horseshoe, no, I'm sorry, is false. I'm sorry. See, everybody makes a mistake. One of the things about truth tables for me is they're really about kind of, you have to be really careful not to get in a hurry and make a mistake. And then true horseshoe true is true, false horseshoe false is true, and false horseshoe true is true. And so what I'm saying is, like, with that, usually we leave the last line we looked at uncrossed off, and we just put a box around to say, these are the cases. When A is true and B is true, it's a false statement. But if A is true and B is false, if A is false and B is true, or A is false and B is false, it's a true statement. The only time it's false is if A is true and B is true. Now, what I was saying about being careful is, you know, a lot of times, like, we get in a hurry and we're like, T, F, T, you know, you don't write real carefully, or you just don't think quickly. One thing that I think, one of the best things about truth tables is it forces us to slow down. When I was a copy editor, one of the things we had to learn was when you're trying to check things for spelling is, it's really easy to be very kind to people. And if you see a word like, you see Wednesday or something like that, or, Wednesday, something like that. It's really easy just to look at that and just be like, okay, it looks right. But one thing is you can very quickly look past a misspelling on a word like that. What you have to do is you need to slow down and actually look at the word. Now, in a story, you have spell check, but a lot of times, like if you're on a copy editor and you're doing a page or anything else, the headline is the main thing. And so one of the things we would always learn is when you read a headline in a newspaper or a website, you always read it backwards. So if it's like dog eats man or something, or dog bites man, I think is actually the one that always goes, is you always want to read it man bites dog. When you read the sentence backwards, it forces you to look at the word itself rather than to look at that. And I think the same thing's true with truth tables. It forces you to slow down and not try to do it too quickly. And so that's one thing to keep in mind, is don't get too quick about doing this. So if you have a statement, so I said, we have 2 to the power of n, but if you had a statement like A horseshoe B parentheses wedge C dot A, well, in this case, how many letters are there? Well, you go 1, 2, 3, but this is the same as before. So we don't add that again. We have 3 unique letters. So we go 2 to the power of 3, which equals 2 times 2 times 2, which is 4 times 2, which is 8. So we need 8 lines. So we start off and we go true, 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 false, 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 and then we go with true, true. Half of 4 is 2, so true, true, false, false, true, true, false, false. And then we come down here to C and we go true, false, true, false, true, false, true, false. Having lined paper sometimes helps with this. Now the other thing is when you have an A, you've assigned it true, 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 false, 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 false. You need to make sure that on this line they match. So if you've assigned it that way, you can't now go true, false. You have to keep it true. They have to match, because this is saying A is true on this line. This is an example of when A is true, B is true, and C is false. So if they don't match, it's like adding in another statement or some other concept in there, okay? And then you do it and you go false, 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 false. You then do the dot and you go true, false, true, false, and then false, 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 false. And so you then go horseshoe, it's true, true, false, false, true, 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 true. The antecedent's true, false, so it doesn't really matter what the consequent is. And then you do the wedge, and you have true wedge true is true, true wedge false is false, false wedge true is false, I'm sorry, true, and that's true as well. True wedge false is true, false wedge true is true, false wedge false is false, and since all these are trues, that doesn't matter what the other one is, they'll all be true. So the only time that this statement is false is if A is true, B is false, and C is false. Otherwise, it will be true. Now, the other thing we learn is, suppose you have something like A dot B, horseshoe, brackets, E, wedge, F, dot G, and something like that. We now have 1, 2, 3, 4, 5 letters to the power of 5. That's 2 times 2 times 2 times 2 times 2. That equals 32. That means you're gonna have to start off and go T, 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 32 times, okay? And then you have to do, actually T will be 16, and then F will be 16, and then T will be 8 and 8 and 8 and 8. And then this will be 4 and 4, 4 and 4 and 4 and 4. And this will be 2, 2, 2, 2, 2, and this will be TF, 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 that kind of thing. So you need 32 lines, which becomes a very big, this takes a whole sheet of paper to do. I'm not gonna do it here, but that's how that works. All right, I'm gonna go ahead and stop so that I can restart here in just a second, okay?